Okay then, first off, on this one, completing the square we are told to do, and we're starting off with x squared plus 2kx minus 7. First thing we always do is half of, so that line should be there, that middle line shouldn't be there, half of positive 2k. What's half of positive 2k? Yeah, just positive k. So we will try x plus k all squared to start with. Either do it in a grid, any way you like. I'll tell you what that bit is for now. X squared plus 2kx plus k squared is what you will have for that. Okay? That is what you have. What you need is x squared plus 2kx minus 7. That is what you need. So, just like normal, even though there's a k in here, we are still asking ourselves, okay, what is the fix? What do I have to do to get from positive k squared to minus 7? Some of you may find it easier to think of writing a naught in here as a sort of staging post. To get from positive k squared to 0, you need to take k squared off, and then to get from 0 to minus 7, you need to take 7 off. So that is our fix, which means we end up with x plus k all squared minus k squared minus 7. And we've got to find the roots of this. So we would just go about doing this the way we would normally go away and solve it. What's the first thing that we do if we're solving one of these? Is anybody else brave enough we haven't heard from yet? I haven't heard from very much. Okay, I've heard from you a lot as well. Okay, yes. Shift this bit here to the other side. First thing we've always done is shift the number bit, and this here is all the number bit. Shift that to the other side. So we will keep our x plus k all squared on the left hand side of the equals. These will both become positives on the other side of the equals. What is the next thing then that we will do? Yep. Square root is the next step. Yep, square root. So we lose the square on the right. The k squared plus 7 is square rooted on the we lose the square on the left. Write the right hand side in a square root sign with a plus or minus. So even though there's a k there which is making it nastier, we still follow exactly the same rules. What will I do next? Because I want to know what the x is. Minus k from both sides. So I will put a minus k at the front because we normally write it at the front. So I get that. And it says, find in terms of k the roots of the equation. That's it. That is the answer. That is what x is. So that is a perfectly good answer for part B.
So you'll find it in terms of k?
Yeah, in terms of k, that's fine. In terms of k means k's are okay in the answer. Okay?
Does finding the roots mean?
Finding the roots means find out what x is equal to.
Okay.
Okay, so that's fine. That is it for that bit. Okay, so that's absolutely fine. In terms of k, okay, up here, so in terms of k means you can leave k in your answer. The roots just means find out what x is equal to. So that is it. Sorry, that's part A, not part B. That's part A. That's part A. Part B says, prove that for all real values of k, the roots are real and different. What one-letter word beginning with D should we be thinking about if we want to know different roots? Should be a word beginning with D that we came across. The discriminant is what we need to be looking at. If it's got two roots, we need to look at the discriminant. Okay? The discriminant is that b squared minus 4ac. We were starting off with this equation. A is 1. What's b equal to? How many x's are there here? 2k. B is equal to 2k. c is equal to minus 7. Okay, the number of x squareds, the number of x's, the number bit on the end. b squared minus 4ac is going to be b, which is the 2k, all squared, minus 4 times a times by c. I'm going to be picking some names at random now. Gracie. Where's Gracie? You Gracie? What is 2k all squared? Square the 2, square the k. Yeah, that's 4k squared. Over here, I've got negative 4 times 1 times negative 7. Anybody want to shout out the answer to that? 28. What sort of 28? Positive or negative? Positive 28. Okay. Now, we need to know for the discriminant, is it less than 0, greater than 0, or equal to 0? Those are the cases. This thing here, 4k squared plus 28. Is it less than 0, greater than 0, equal to 0, or have you not got a clue? Why is it greater than 0? But you put a number in, I could come up with a different number. Go on. Yes, thank you. Okay. Anything squared is always positive. A minus squared is positive, a plus squared is positive. K squared is therefore always positive. 4k squared then is always positive. And if you're adding a positive thing onto something positive, that's always positive. So what we have here is b squared minus 4ac is greater than 0. And if you look back in your notes, if the discriminant b squared minus 4ac is greater than 0, that always leads to two different roots, which is what you had to show in this question, that they were different roots. They weren't, when it says real, that means they're not these imaginary numbers, you haven't got squaring of a minus number or anything. And the very final bit of this question we can squeeze in before the bell. Part C, it now tells us that k equals root 2. Find the exact roots of the equation. Well, earlier on, we had this written down. Okay, that was our answer to part A. It's just a case now of replacing every k with a root 2. And you should get that. Root 2 squared is 2. 2 plus 7 is 9 is 3. I'm going quite fast because the bell's going to go fairly soon. So I've got, well, that's it. You can leave it like that. There's nothing wrong with leaving it like that. If you want to write it the other way round, you could do. But either of those are fine. That was another A-level question.